This conference will now be recorded.
So thank you very much all for joining us, and in particular to Dr. Stefano Canessa, who's a postdoctoral research fellow at the Faculty of Veterinary Medicine in Ghent University in Belgium, and is involved very heavily in work. All of his work really is focused around how best to avoid extinction of threatened species, and looking in particular about how you make better decisions, and a whole range of other stuff as well. And Stefano is going to talk to us today, give us an introduction to a tool that is used quite widely and I think has huge potential to be used to inform decision making and the generation of information that might be otherwise difficult to get hold of through expert elicitation. So on that note, I'm going to hand over to Stefano to put on his webcam, do his introduction, and then Stefano, if you'd just like to get started, I think you're going to explain when you'd like to be able to take questions either during or the webinar, and it might tie in with a bit of an activity as well. But I'll say no more, and I will hand over to you. Oh, you're frozen.
This conference will now be recorded.
That would be great.
Yep, I can change my webcam. So let me see. Just a sec. I should try this. Can you see me now?
Not yet.
What about this?
Oh, you're teasing us now. No, I can't see.
It says there's a reason. Yes. Okay. So I haven't started with the slides. I'm going to put the slides on.
Yeah.
And I'm going to start again my introduction. Hopefully the connection is good enough.
That sounds very clear now.
Yep. So, as Jamie mentioned, I'm a postdoc at Ghent University in Belgium, and I've got a range of interests, but research interests, but all have to do with conservation of threatened species. I work in mostly quantitative ecology. I use demographic models of species, and I'm especially interested in decision making for conservation. So I've worked with a number of research and recovery programs for species in Australia, Europe, the US, New Zealand, throughout the Pacific, and so on. So the research I'm going to talk about today, and Amy, please let me know if this is visible now.
Yes, all visible now.
Yeah. There's a lot of research that I will be discussing.
Now we've lost you again.
As I do every time. So the title of the talk is Expert Elicitation. So we look at some principles and methods about using experts to inform conservation decision making. So just to go quickly through the structure of the webinar, I'll give a quick definition of who experts are and why we can't do without experts in conservation. I'll highlight some problems that might arise when we talk and we work with experts or we are experts. Then I'll stop for a minute and I will give everyone an opportunity to ask any questions. Then we'll look at some practical tips and some methods for eliciting the opinion of experts in a way that reduces or eliminates those problems. And I'll talk in particular about the IDEA protocol, so a formal process for expert elicitation. And then I will stop again for another couple of minutes. We can have questions, we can discuss, and then last few minutes, probably 10 minutes will be an exercise. We'll try to go through an elicitation process that at least I hope will give everyone an idea of how this would work in a workshop setting, which is when we typically use these. Okay, and then there's a slide with some recommended reading, which is also cited throughout the talk, and there will be another opportunity for comments and questions. Okay, so let's get started. Why do we need experts, and who are they? Well, planning in conservation, as pretty much with every other type of planning, needs information. Okay, planning is basically making decisions, either things that we do now or that we need to do at some stage in the future. And to do this, we need information. The first thing is to know what the status of a system, of a species, of a habitat, of a population is. And in this example that I've just made up, you can see there are data about this population until about 2009, and the population seems quite clearly to be declining. But then the data stop, and so if we need to make a decision, maybe people haven't collected data for the last 10 years, maybe there wasn't enough money, funding was cut off, and we have uncertainty. So we need to know what's happening now. So we have this information is missing, and we will need to fill this gap in some way. We might turn to experts of the species or experts of the place where we're monitoring the species, or both. Another case is where we have management actions. We have options. We have different things we could do, but we don't know how well they would or they will work. In this study that we did a couple of years back, we asked experts about mitigation of a disease of salamanders. So because no one has ever attempted to manage this disease in the wild, we've got some fragmented data from lab studies, but we don't have information about the possible options. And the options are here in this list, different treatments that experts thought could be used. And we asked them, how effective do you think these actions will be on these two metrics? Okay, so we can then compare which action has the highest probability of success according to experts, and then choose it, implement it, and see if it works. And then, of course, if you're familiar with the CPSG process, at least with the PHVA process, or in general with any PVA, population viability analysis, or with any modeling, models require information, data, or parameters, such as numbers that go in, so you can get some other numbers out. And often you don't have those numbers, or they are, again, fragmented. You need to infer them from some other situation, some other place, or sometimes you're just in the dark and you have no idea. And then again, you might turn to your experts to ask them, what do you think this value is? What do you think this example? I don't know if you can read that, but what do you think the age of first offspring females is? Someone entered 7. That could be data, but it could just be expert opinion. So we need this information. However, did you speak, Jamie?
No. No, I'll just check there's no other microphones on. Please continue.
Yeah, thank you very much. So we need this information, but this information is going to come with uncertainty, and probably you could argue that we're never going to get rid of uncertainty. It's always going to affect at least conservation, because our knowledge is limited. No matter how good the data you have, there's always going to be some aspect that you don't know about. You can always learn more. And sometimes, well, often actually, I think in natural systems, even if you know everything, systems are variable. Okay, we can know exactly what regulates the weather. It's still pretty hard to determine, if it will rain in a week's time. And think about, mitigation or conservation of a species. We might know exactly how a species responds to rain, but we don't know whether next year will be a good year or a bad year. It will rain, if there will be a drought. And so this inherent variability creates uncertainty. And sometimes also the language we use generates uncertainty. Okay, we might not have clarified every definition in the best possible way. Sometimes, I assume that viability means one thing. Maybe, the other expert thinks viability is another thing, another probability of species extinction or another minimum population size. And so this also creates uncertainty. So although we hear, and I think they're perfectly justified, increasing calls for conservation to be evidence-based, experience-based decisions still dominate, meaning that we don't have empirical evidence for everything. And even where we have it, it's often fragmented, it often needs to be interpreted, or it needs to be synthesized, because it may be information about different aspects of a system, but we need to manage the system as a whole. And so in these cases, we turn to experts. Okay? So the US National Research Council defines experts as people with indispensable substantive knowledge, methodological skills, and experience. So we see experts as people who have access to information that non-experts don't. So they know things. And because they know things, they have superior access, we also attribute to these experts a superior ability to interpret evidence. Okay, not only does an expert know more, but he can also more easily or more effectively than non-experts interpret what new information means. This sounds reasonable, I think, but having a clear-cut definition of what an expert is and who is an expert and who is not, it's not as clear-cut. Okay, it's not as easy. Typically, we turn to things like years of experience, or number of publications, or academic qualifications, or sometimes there are even more intangible things, like some people just look very confident. Sounds silly, I'll talk about in a minute. But just to give this idea that expertise or the status of an expert is something we attribute to them. And we also attribute expertise to ourselves, okay? So you can see here, this is an interesting study in PLOS One, so it's open access by Bergman et al., where you can see the correlation between how people ranked themselves from 0 to 10 as on the y-axis as experts, so 10 being the gurus of the field and 0 being rookies. And then on the x-axis, you have the assessment by peers. And you can see that people tend to be modest, so they rate themselves a little bit lower than peers do. Only some people really overrate themselves. But in general, there is a nice correlation. Okay, so these tangibles and intangibles are somewhat shared about what makes an expert. So we expect experts to be better, as I said, in having more information and being better at interpreting that information and novel information. And also, experts often think the same of themselves. There will be problems. For example, in this case, you can see that this was another study in conservation biology, and you can see that on the x-axis, you have the experience of practitioners, in this case, conservation practitioners in the field. And you can see that the correlation between the extent of that experience and, in this case, access to scientific information, so awareness of whether there was information published on a given topic that the researchers asked the expert about, the correlation between the years of experience and the access to that information was pretty much non-existent. Okay, it didn't matter. In terms of practitioners' experience and having actually tried themselves some different types of intervention. This is also a very nice cloud. So you can see, although there's a positive trend here, I would probably question the significance of that. And I'm sure the researchers in the study did too. So again, it doesn't mean that because an expert has been in the field for many years, they've tried, they have experience with a broader range of interventions in this case. So this is just an example that this attribution of the status of expert might be misplaced or misguided if it's based only on this type of trait, like years in the field. So I think experts, well, it's reasonable to say that experts are necessary in conservation. There are some pitfalls. Before I discuss those more in details, I thought I would just check for a second if there are any questions. And I think perhaps it's also a good time to point out, Jamie, especially any technical issues with the presentation so far.
Thanks very much for that. So it's actually it's coming across much clearer now. Actually, if you turn your webcam off, maybe that will also it's going to help with the bandwidth. So, are there any questions or clarifying questions? Anything that Stefano's been talking about just now? So Vinicius has come back saying you may be able to see it, Stefano, but to look at non-scientific experts, such as those with traditional knowledge, are they considered? So I suppose, what do you define as an expert?
Yeah, well, that's a good question. I might have given the impression that I'm only talking about scientific expertise, and certainly that will be the case in my examples, because that's really my the area where we mostly work. But in this case, expert is someone who has information about things that we need. Okay, we've worked with iwi, so Maori communities in New Zealand, about their cultural values in conservation, and because their values were affected by some conservation actions that could be taken. This was not scientific knowledge. It was knowledge about the Maori system of values. So in this case, for me, they were experts. That's enough, really. In that case, they had access to information that we didn't have, and they could interpret other iwis, other Maoris' positions in a way that we couldn't. So I think the same principles apply. Some methods that I will describe are more quantitative, but the principle, I think, is the same. But it's a good question, because we sometimes perceive experts as scientists. Not necessarily. Depends what we want.
And Patty has asked about gender differences. Are you able to respond to that before we go back to the presentation?
I'm going to talk about some issues with experts, but yes, we have. Well, I think most of us, I hope, will be familiar with lots of implicit biases. Gender bias, age bias, ethnic group bias. Depending on the society, in my case, where I come from, I could think, class differences, things like that. All these things influence, self-perception, perception by others, group dynamics. We'll talk about group dynamics in a minute. Confidence, all these things. So these are part of the pitfalls that I will discuss in a minute. So it was very good to highlight them already. And we need to find methods to minimize or eliminate those biases when we ask people for their opinion. Yes.
Thanks very much for that. Please carry on.
Yep. So let's have a quick look at those cognitive frailties of experts. So as we've just mentioned, there's lots of implicit biases in the human mind, and even the same expert, depending on the context of the question that they're asked about, their mood that same day, their personal life, influence what estimates they give. And I think there's some nice research about judgments made right after lunch or right before dinner, where the opinion changes a lot. The information available to an expert doesn't change, but depending on how empty their stomach is, the answer they give can be very different. And especially when the expert is a judge who decides whether to send someone to prison, that bias has massive consequences. About environment, I was reading the other day a paper that said that in a couple of hours, 3 people in a meeting room can generate enough CO2 to impair thinking. So if you're making a decision at the end of the day, even if you have the same information, the same expert, the same dynamic, the same people in the room, the estimates made by experts could be very different. I'm not accusing anyone. Of course, this would be silly. These are not moral judgment. We know these biases exist. Just as gender biases, the ethnic group biases that I mentioned before. If we know they exist, then we can correct them. So the first thing that experts do, I really recommend you have a look at this paper because it's fantastic. It's a very short piece again, open access in Nature, and it's a fantastic piece by 2 key scholars of the field. So the first thing that experts do is overestimate themselves. They can be overconfident. They overestimate their accuracy and precision. And it's interesting that this overconfidence, which is a relatively well-known phenomenon in psychological research, increases as more information becomes available. So as people feel they have more knowledge, they tend to become overconfident, to overestimate how much they know and underestimate how much there is still to learn. As questions become more difficult, people become more overconfident. Perhaps, again, when the brain can't handle the thing, we have a tendency to just cut corners and just overstate our confidence. And in the absence of feedback, again, overconfidence becomes worse. So if you interact with experts, you want to give feedback about how well they have performed if you have that information, because otherwise people will assume that they've done well and reinforce any previous bias. Okay, so again, a very nice paper that comes from the research group at the University of Melbourne. So another paper. I really like this study. So let's concentrate on the black dots here. On the x-axis, you have the peer assessment. So 1 is, let's say, a rookie in the field. And 9, you have the big expert in the room. And on the y-axis, you have error. Okay, so the higher up you are, the further away you are from the truth. And here, the people who ran this experiment knew the truth. So they could check how close experts were to the true answer to the question the researchers posed. And the interesting thing is that those perceived by others, not just by themselves, as more expert, they were not necessarily better. Okay, so in some cases there was overconfidence by themselves and by peers. Okay, and you can see now just going with peer assessment as a measure of reliability in this case would not be a good idea. Whereas people that were relatively ignorant or new to the field, they had on average better answers. The little crosses, we'll come back to those in a minute because that's also interesting. Okay, so overconfidence, a problem. Probably the main problem. And of course, again, we have mentioned innate biases, and I'm sure everybody who's been involved in workshops or group planning for conservation and elsewhere will be familiar with things like group dynamics, where dominant personalities in the room can drive a discussion and influence everybody else. How a person who sounds very confident is more likely to bring the rest of the group to their position, and so on, and without going to more problematic things like aggression in the room or so on. So experts have these problems, but we still need their opinion. We need their opinion because we need to make decisions that are urgent. So there is no time to collect empirical data sometimes. We need experts because they know what is known about the system and what is not. So we need to estimate uncertainty and we need to make predictions. So how do we fix problems like overconfidence? Well, in part, this is down to facilitation skills, which again can be divided, I guess, in the art of facilitation. So being able to lead a group through a discussion. Being an art doesn't mean it can't be learned. And I'm sure Jamie has a lot of experience in these settings. So knowing how to lead a discussion, but also how to select a group before we get to the meeting or to the elicitation process, and then using more technical tools like I will discuss the Delphi process in a minute, and giving continuous feedback to those experts, because remember, feedback reduces overconfidence. And partly we can solve these pitfalls by quantitative treatment of information. Okay, so I'll present in a minute how to do a 4-point elicitation, how to put estimates by different experts together, and how to give weights to different experts. Okay, so just to recap where we got to in the first half hour, expert opinion is fundamental in conservation because it's really often inevitable, no matter how evidence-based we want to be. But experts have biases and frailties, often unconscious, so it's not their fault. And we have some practical solutions and formal protocols to minimize or eliminate those biases. Before I go into those tools, I would like to ask again if there are any questions, and again point out if the sound has failed. Thank you.
Thank you. Yeah, no, all is very good. So does anybody have any questions, if I can get to grips with my own language, before we carry on? I'm quite tempted to move on, because it would be great for people to be able to kind of contribute to the activity and then to see some of the results. So be able to get into some practice would be wonderful. But I'll keep an eye on the chat room and see if any particular questions come up as we go. Is that all right with you, Stefano?
Perfect. Yeah, I can't see that now, so that will help. Thanks, Jamie. Okay, so we want to do an expert elicitation. What do we want from it? First, we want it to be relevant to our problem. We want to ask experts a clear question, and we don't want them to go off and rant about something else. We want the judgment, the opinion of experts to be accurate, to be close to reality, because that's what we need. We want it to be useful, so we want to be able to make decisions based on expert. We don't just want to know what they think. We want to be able to use that information for our purpose, which is to plan. And we want it to be explicit. So if there is something that experts don't know, or if there is something that is 100% proven, probably less likely, we want to know. Especially planning carefully how we deal with uncertainty is necessary, as are, I think, some data synthesis and skills, analytical skills. But these, you'll see, are very, very simple. Okay, so some tips. How do we fix some of those biases of experts? Well, groups, we know, because research shows that groups perform better than individuals. This is another study, actually in the same paper that I showed before. So the researchers in this study ran a few workshops, and almost always the person and remember, on the y-axis, the lower the better, the closer to reality. And almost always in a workshop, the average of a group estimate, and remember, the group included people who were perceived themselves as big experts, and others who were not so much. And the average of the estimates of the group almost always outperformed the person perceived to be the biggest expert in the room. Okay, almost always they were closer to the truth, and they had a narrower range of uncertainty as indicated by these confidence intervals. Okay, even in the cases where they didn't outperform in terms of being closer to reality, you can see they largely overlap. So it's rare that a group does worse than an individual. Diverse groups produce better judgments. And this can be diversity in a general sense, in the sense of gender diversity, ethnic diversity, background diversity, keeping in mind that we still want to remain within a general area of expertise. We can't just pick people from the street. Okay, we're still talking about people who are somewhat experts in the field. But remember this study that I showed before, and how I showed the black dots, and the people who were perceived as more expert not necessarily performed better than the rookies in the field. But this was the first round of a discussion. When experts were shown these results and were then given a chance to update, revise their estimates, so they had been presented or challenged by either new information or new lines of thought, then they were given a chance to revise their estimates, and the experts were the ones that improved the most. So you can see the little crosses are the second round of discussion, and you can see the lowest status experts remained more or less where they were, but experts really improved a lot. So in this sense, perhaps they were truly superior in being able to interpret new evidence. But again, the presence of these people in the room, and I think I would say that, at least from my experience, this experience proves it, a diverse group, these people in the room were still needed because they really stimulated experts to up their game. Okay, so again, this is an excellent paper by Sutherland and Bergman. A few tips: use groups because they perform better than individuals. Of course, choose members carefully. Pick people who have some knowledge about a topic, but don't be starstruck. Don't think that the perception of status equates reliability. Avoid homogeneity. So again, diverse groups perform better. Don't be bullied. This is a reference to the group dynamics that I mentioned before. Just because a person is assertive, looks very confident, or can even be aggressive in a group, don't think that's the case. And you can counter these with facilitation skills, like having small groups, or in the idea protocol that I will mention in a minute, go through individual elicitation before you throw questions out to a group. You can attribute weights to experts. So if we had to calculate an average estimate from this group, we could give every expert a weight, and so some expert might contribute a bit more to the average. But again, this is a bit tricky because you need some measure of how reliable they are, and we've seen that you can't just go on age or perceived experience. And then train experts. So if you want to do the exercise that I'll show, it pays to prepare people beforehand. Try exercise because sometimes it's a bit counterintuitive at first, and give feedback. So show people. You can see here, after the results were shown and people were given a chance to discuss, they improved a lot. So this feedback improves judgments and reduces overconfidence. So this it's a very nice protocol that we've used many times. Again, comes from the very smart people down at the University of Melbourne. Idea protocol. So investigate, discuss, estimate, and aggregate. Okay, so we have pre-elicitation phase, where of course we want any information that exists, as in data, published studies, previous reports. We want that to be available to everyone. And we want to assemble the group very carefully. Okay, then we investigate. So we ask experts to give their estimate individually. Again, we do this individually to avoid those group dynamics, those negative biases where we hear the guru in the room and we think, oh, they are right, or they're speaking very loud, so I should believe them and not myself because I'm just a student. Incorrect. By doing this individually, we ensure that people follow their own thought process, which will be vital later on, because then we will give feedback. So we might present those initial estimates and open the thing, open the discussion if necessary. Any new information could be brought to the surface. Again, we could maintain the estimates anonymous. It's fair. So if people don't want to be threatened in their perceived or self-perceived expertise. And this discussion is then really where things happen, when people explain their thought processes, where problems or biases or lack of information comes to the surface, and then we allow experts to make a second, again, private individual estimate. So they can stick to what they stated at the beginning, or they can revise it and change it. Okay, we can repeat this several times, so it can be a sort of cycle. Usually 2 rounds is enough. Usually in conservation workshops, there is not a lot of time to do more than this. But we can also we will work on the estimates after the elicitation. So we need to decide how to aggregate, how to put those things together. Okay. And again, this is a good time. The discussion especially is a good time. Remember that what I called linguistic uncertainty. So whether maybe the question was not clear at the beginning, maybe we were talking about the wrong problem, and so all of these things are allowed to come to the surface, which makes it possible to solve them. So this method of individual discussion, group discussion, and individual revision is what we call the modified Delphi technique. Okay, so it provides this opportunity for feedback and discussion, but also ensures that the diversity of the group is respected and actually fully exploited, because that's what really creates the benefit, is to be able to, if I may say so, to ask silly questions, because sometimes those are the ones that really highlight the gaps. Okay, so the more technical, so this is how to lead the discussion, but technically, if we want, and here I'm going to talk about a more scientific application, but if we want, for example, parameters for vortex, or we want to estimate probability of extinction of a species, or we want to know the number of individuals who will eat the supplementary food we provide, or the number of animals we can catch next year of those that we introduced this year. These type of questions, they have to do with numbers. We typically use a 4-point elicitation. So again, this is a method that was developed, at the University of Melbourne and other smart people, where we ask people not only for one value, but we ask for a range of values, so the minimum and the maximum. So what's the minimum plausible probability of extinction, for example, if we vaccinate all animals in the population, and what the possible maximum? And then we ask for a level of confidence. That range between minimum and maximum encompasses the truth. So I could say the probability of extinction of a species is between 0 and 1. And because the probability cannot be lower than 0 or greater than 1, then my confidence that the range I've given contains the truth is 100%. I could define a much smaller range. I could say between 0.75 and 0.95, but I might be a bit less confident. So there is a chance that I've just missed the thing altogether, and so it could be 80% confidence. We'll do this in the exercise in a minute. This method has been demonstrated to be, again, reduced overconfidence, and also gives a transparent indication of how much uncertainty there is in the room. Now, quantitative estimates are sometimes a bit uncomfortable to elicit because people might be used to express judgment verbally, to say, I think it's very likely that this food, providing this food, will benefit our population, or I think it's unlikely that adopting a soft release for a reintroduction will improve its outcome. But using words again opens up to that linguistic uncertainty. So you have an example, published study where people were asked to link words, verbal definitions of probability with actual numbers, and you can see how different the interpretation were. So when we said rather likely, some people in the room thought that rather likely meant 15% of the time, and some people thought that were meant 99%. So it's something they would call almost certain. Some people would define it as rather likely. Okay, so if we use numbers, we at least know what these mean. Okay, sometimes it's possible, sometimes it's not. And then, of course, because we want to use groups, because remember they perform better than individuals, we need to bring things together. Okay, so every expert will give their opinion, their estimate, with a range of uncertainty and their confidence. And because, we might weight experts or not, but in any way, we need to obtain one group estimate. This is different than looking for consensus. Typically in this process, we don't need consensus because if there is uncertainty in the room, we want to recognize it. Okay, so if experts disagree, that's a piece of information we don't want to overlook. We want to understand why they disagree, but we want to express a group position. We don't want people to converge. And again, consensus could have pitfalls in that. There may be group dynamics that make convergence a bit undesirable. So we could, looking for consensus could be something that we called as behavioral aggregation. So we just discuss things with the group until we more or less converge to a solution, which could still recognize uncertainty. Or we could just use the estimates of every expert and aggregate mathematically. So I think in the idea protocol description, they just stated like the mean of experts. Okay, so this could be the mean of the best estimates and then the mean of the intervals. Or we could use a more probabilistic method. Again, the methods are in the papers that I indicated in the PowerPoint. So just to wrap up, and then we can try it. It's really not more difficult than this. This is work that we did, we've done in the last few years with experts in the Netherlands, where they had a problem that they wanted to reintroduce salamanders in a place where there was a fungal disease that might have killed them or not. And so we assembled a group, in this case of 12 experts, and we followed what I mentioned. We had the modified Delphi process and this 4-point elicitation. So you can see here, well, we have two scenarios, whether the disease is present or absent. That was specific for our case. And then we have actions. So we could just do nothing and let the population go. We could just do some in situ management, or we could do reintroductions with animals of different origin. And what we asked here in this case, I think, was the probability that each of these actions would result in a viable population of the species. Okay, so we asked people, if we do nothing and the disease is absent, what's the minimum, realistically, what do you think is the minimum probability that a species will still be there in, I think it was 100 years? Realistically, what do you think is the maximum probability? What's your best guess? And how confident are you that this range of minimum and maximum contains the truth? This worked quite well. So we took the average of groups and then we fitted probability distributions and we produced a plot like this, which we then used to judge that doing nothing was the least likely action to result in a minimum viable population, and doing reintroductions with captive individuals was the most likely to achieve our objective. And this then informed management decisions. Okay, so this is how it works. And you can imagine in a workshop, we discuss this, we come up with the questions, and then we give this table to experts and they fill it. And then we aggregate, discuss, show some plots, discuss again, show some more plots, revise things, and so on. In this case, for a couple of days. Okay. Right. So I think we got time to do the exercise. Let's just recap what I talked about so far. So expert opinion is fundamental in conservation. It's actually inevitable in many cases. Experts have pitfalls, but we can employ some practical solutions, use groups, choose your experts carefully, try to minimize group dynamics and implicit biases. And also you can use formal protocols. We can ask for intervals rather than simple single parameters. We can use Delphi techniques, so mix individual and group discussions, individual reasoning and group discussions to get to our best estimates. Ideally, we like to work with numbers. Sometimes it's impossible, but whatever we do, being transparent about uncertainty is vital. Okay, hiding it is not admitting that we don't know things. Doesn't create knowledge. It just makes it difficult to solve, to find the gaps. Okay, so before we do the exercise, are there any more questions?
Stefano, I'm going to override any questions anyway, because I think we should go to the exercise. I'm really keen to see what comes out. I'm keeping an eye though on the text box, so I think they're just.
Excellent. Oh, thanks, Jamie. So we got let's say 10 minutes should be enough. So imagine we are sitting at the workshop where we need to make decisions about the conservation of latent albatrosses. So species of pelagic bird in the North Pacific. I need, as the decision maker, or maybe I'm a person building a model of the species, I need to know the probability of survival, annual survival, of adult female albatrosses that do not breed in that year. Okay, so when an adult female albatross does not breed in a year, what is the probability that it will survive to the next year? This is the question that I will pose to you as experts. Okay, we'll go, I don't know if we can do the Delphi process because we're not in the room, so it's a bit difficult, but we're going to do the 4-point estimation. Okay, so I'm going to ask 4 questions and you can think about it. You can write things down and then write your answers in the chat box. So the first question is, realistically, what do you think the lowest plausible value for survival will be? And this is a number between 0 and 1. Okay, so if you think it's 20%, write 0.2. The next question is, realistically, what do you think the highest plausible value of survival will be? So this is the highest possible. So technically, there is a hard boundary here, so it can't be higher than 1, but you might think realistically it's never going to get to that point, so it might be something a little bit lower. Third question is, realistically, what is your best guess? So if you had to put all your money on one single value within that range of minimum to maximum that you've just given me, what would that number be? And again, another number between 0 and 1. And now the last question is, how confident are you that your interval, so the lowest plausible value to the highest plausible value, could capture the true value of survival? And I would ask you to enter a number here in percentage, so between 50 and 100. And the reason why I'm saying more than 50 is because if you think about it, if you said 40%, it means that you actually think it's more likely that the truth is outside your interval than inside, which I don't think makes a lot of sense. So we want to avoid that. Okay, so I want these 4 values to this question: annual survival of non-breeding adult female Laysan albatrosses. And I'm going to write the question in the chat box. Makes sense. Okay, and I'm going to example. Okay, I'm going to, for example, I think the lowest possible value is 65%. I think the highest possible value is 85%. And my best guess is something in between, which will be 75%. And I don't know much about albatrosses, so I think my confidence is 80%. Okay, so there's a chance that I got that wrong. Okay, can you see this in the chat box?
Perfect. So should we? We're obviously not going to be able to take ideas from everybody. So we're going to kind of go with the first ones that come in to be able to get the point. And we've got a number of them coming in already. So keep them coming. And then Stefano, is it easier for you to just read, or shall I read some out until you've got enough?
I'm just looking at those. I made up the answers because it would be impossible. It would take half an hour to take these numbers and put them in. So I'm looking at some numbers now. Yep. I'm looking at some. We've got some very low numbers, like 25%, 40%, 30%, 30, 40. Yeah, this one is a bit higher, so between 90 and 95%. Maximum, I'm looking at the maximums now: 80%, 60%, 95, 75, 80, 65, 1. Okay, that's about as high as you can get. Maximum 85. Okay, perfect. I think the numbers are very good, and you're all quite confident. 90%. Look at that. 90%, 80%. Oh, that's me, because I'm overconfident, but I know the truth. So here I've just made up some numbers. Okay, these are true random numbers. So excuse my Belgian computer where points are actually commas, but you can see this is the way I would treat this. So I put the maximum, the minimum, the mode, and the confidence. And then we use a method. We just use a simple formula to rescale this. So everything is on a scale of 100% confidence. Okay, so we can compare them. If you're very confident, the rescaled values will be very close. If you're not, the interval will become wider than the one you stated. Okay, so in this case, it was between 23 and 53%, but the confidence was low. So we have rescaled, and you can see the 100% interval is much broader. It goes from 13 to 63%. Okay, that's about it. And then at the end, I take the average. So I'm looking at this. This is the average of the group. Okay. So we got a maximum of 62%, we've got a minimum of 25%, and we've got a max mode, in this case, the most likely, of about 50%. So these are the estimates of individual experts, and we've got the average. Okay. Now I've done this a few times, and I thought about this, and I've read the paper where these values are estimated. So the way I would think about this, and then again, I don't know much about albatrosses, and the way I would ask the question in the discussion is, how long does an albatross live for? They're big birds. They are slow as a life strategy, They don't lay many eggs. They take quite a while to mature. Actually, I think their lifespan is probably comparable to humans. What's the chance? And I expect to live as a male in my country. I expect to live about 80 years. So probably comparable to an albatross. I think my chance of surviving to the next. I'm not a female, okay? I'm not a female, but I haven't bred yet. I haven't bred either last year. But to live 80 years, I think my chance of making it to the next year is higher than 25%. Otherwise, I would be locked inside my house. So actually, I think it's pretty high. And you could even calculate this. You could even do a simple calculation, which is, if my survival is 25%, I don't know if you can see the formula, and I expect to live about I expect to live about 70 years. I need Belgian. Sorry, I need the Belgian comma. That's the probability of making it to 80 years of age, and I know that's way too low. So the number probably has to be much higher, probably something around 95%, and even that. Okay. So this is the type of information that could surface, or just thought process. I only needed some information about how long does an albatross live for, until the next year. And so this is the type of information that could surface in a discussion. So in this case, I could ask you to revise your estimates if you want. So you can do the same thing, but send me some more estimates in the chat box. And I'm going to revise. I'm going to say that mine would actually be too low. I think it's going to be 85. The maximum is 1. Well, it's never going to be 1. So I'm going to say something like this. And my best estimate is probably something around this. And actually, I am very confident that this is the truth. Okay? So I would revise my estimates based on my own reasoning to something like this. If you want to change, you can write in the chat box. Okay, so some revised estimates are coming in. Excellent. Thank you very much. Well, I don't know if the group has been biased because I'm perceived as an authority on albatrosses, or because I'm very assertive, or maybe I've been aggressive. After all, we've muted your microphones. But this is something that could happen in a second round of discussion. So people might revise their estimates, and typically I would present them with an updated plot where you can see here, I show the group average. In this case, I have the truth. Again, these are random numbers. These are not your estimates. So again, I've created those numbers and I show the truth. Okay, this is the actual value. I think the value was published. I found it published in a paper, and it's actually the point estimate is 96%. Okay, so because we had to rush through the exercise, I couldn't enter your values, but if you go back and look at it, I'm pretty sure the second round of estimates would be much closer to that truth than the first round. And all was needed was, I didn't even get on. I think the only information I gave was the lifespan of an albatross. And even then, I didn't commit to any precise numbers. Okay. I think that's about it for the presentation. So we've done it. This was the 4 points. We could use these estimates in a model to decide about the life and death of albatrosses. So there's some recommended reading. I don't know, Jamie, if you've shared the slides or you will, but this is in. And the last thing I want to say before we're a bit over time, but before we have more questions, is that I developed much of this material for a training course for conservation, translocations, and reintroduction that myself with other colleagues, including Jamie, have been teaching for the last few years. And we talk a bit there about expert elicitation and also how to use different types of evidence for conservation planning and conservation decisions. Okay. I will thank everyone. If anyone has to leave, I take the opportunity to thank you now. But if you want to have questions, I'm ready to hear them, and also to you.
Fantastic, Stefano. So Tanya has a question. We'll just talk for a few minutes on where we are on the hour. But Tanya's asking questions about the exercise itself, about the average of the group biased by the fact that the confidence limits will be larger if your range is bigger. Is that something you can respond to? It's not something I can respond to. The moment you get into statistics, I am totally at sea.
Okay. So 0-1 is 100% confidence, but it's uninformative, right? So I've asked for your best estimate and I've asked for an interval. So yes, we could, if that's the case. So last year, I think we did a conservation planning exercise where we really had no idea whatsoever about what would happen to the species. There was no published information, not even something remotely comparable. We had no idea about our own ability. So yes, it was 0-1. And we are 100% confidence. But that was basically, that's useless for decisions. It means basically we can do anything. But he also told us that we could learn quickly, and that was an important thing to learn about. So yes, the average of the group, that's if you mean the average of the intervals, okay? As I said, you want to be explicit about uncertainty. So if you really are uncertain, state it. I did an average. So the average of the best guesses is not influenced by the intervals. That's the average of the best guesses. Okay, that's just in case there could be confusion between the two things. So I had the average of the best guesses, which is I think in more or less the middle, and then the intervals. So yes, you can. I wouldn't even say biased. It's just that if there is a person in the room that knows nothing, that's part of the group's opinion. So I wouldn't even call it bias. Hopefully, it's a realistic representation of the group. Of course, I could decide then if that person continues to give me very wide intervals with 100% confidence, I could ask them to think about it a bit more, or I could give them a very low weight because maybe they're not such an expert. Or I could think and ask the group, is this really the state of our knowledge? Are we really this uncertain? And if that's the case, then I need to recognize it. But think about if you only asked that person for one value and you didn't have the interval, maybe you would get a very, very biased representation. In that case, yes, it would be biased of the state of knowledge. Okay, that was a long answer to a short question, but yeah, thank you very much.
And I mean, what you're describing here is that the facilitation of that discussion sandwiched between a couple of rounds of number generation has to be very carefully done, doesn't it? Because you can think about who you select and try not to have overly assertive, but you're still having to make sure that people you're not ending up with a sort of a group thing, because there seems to be a dominant, view that's being projected and others are sort of coming in line, that it's actually a genuine movement from my own view based on the information I've now received.
Yeah, absolutely. Of course, you want to minimize the group thinking, and that's why you don't necessarily want that consensus, right? Because you don't want it to be consensus about following someone. But so this is part of facilitation, but the process really helps. So you'd be surprised how sometimes we have the initial estimates that are individual, and then we have a discussion, and someone might hijack the whole discussion and give the impression of being the absolute know-it-all about the species. And then you give people the opportunity to have a second revised estimate, and no one really changes their mind. So this mix of individual, group, you could play with small groups. So if you think there is one person who's having, an extreme effect on the discussion, then break the discussion into small groups. Maybe have those small groups rotate, so people are exposed to this know-it-all, but also to other opinion, and people who are less confident maybe, or just a bit more introverts, give them a chance to speak maybe in a small group. That goes a long way. Yes.
Fantastic. Thank you so much for that. I think we'll probably have to wrap up because people are having to get on to other things. But Stefano, thank you so much for giving up your time for that. It's a superb introduction, really nicely, simply, it was very clearly laid out for everybody. And I'm sure it will spark off other discussions that we'll have on within the online course, those people who are participating within the discussion thread. And I may come back with you with any questions, which are probably all of them that I can't actually answer myself. For those of you who are on the online course, we've got next week is the last week of the official last week of the course. We're looking at that movement between planning and implementation. Although the course is not about doing conservation work, conservation projects, it seems right to sort of think a bit about some of the sort of the oversight of projects that contributes to effectiveness or otherwise. And so we're going to talk a bit about conservation leadership. So please make sure, if you haven't done so already, you've signed up for that one. And Stefano and others this is being recorded. I'll check it with Stefano first, but then we'll make sure it is made available to people. So everybody on this group who's listened today, will make sure you get sent a link so you can listen to it at your leisure as well. Thank you so much, everyone. Thanks, Stefano. Have a very good evening, wherever it might be.
Thank you.